We all good? Awesome. Welcome, everybody. Thank you for coming to the talk. Thank you for choosing me over the Troy Hunt and the C# super panel that's also happening right now. I don't think you will regret it. This talk is build versus buy, and we're going to talk about software systems at Jurassic Park. But first, my dear friends, let me be the first to say, welcome to Jurassic Park. In retrospective, we are going to look very closely, uncomfortably close, at Jurassic Park, the successes and failures our organization had during our first run. We put together this retrospective to share with you, the broader community, all the things that we learned about how to build complex systems, how to choose whether to build something or whether to buy something, so that we can move into our brave new future of the next version of Jurassic Park. But more on that later. So you may be familiar with us. You may have seen a documentary made about our work and the issues that we had. It got some notoriety, but it was vastly over-dramatized and negative, and it wasn't at all what really happened. Our first attempt at Jurassic Park did have some unfortunate side effects, but only 4 people died. And I think we learned a lot from the experience. One of our core problems, which we're going to talk a lot about today, was perfectly articulated by one of our consultants, Dr. Ian Malcolm. And he said, we were so preoccupied with whether we could, we didn't stop to think if we should. And I think he was specifically speaking about our choices in software and which things we chose to build and which we chose to buy. Now, you might be wondering who I am. My name is Todd Gardner. I am the VP of Informatics and Automation at a company called Engine. Engine is the company behind Jurassic Park, a number of genetics and theme park-based companies. Here's where I fit into the overall org structure. At the top was our CEO, Mr. John Hammond, with our general counsel. The top level was Robert Muldoon, the VP of Security and Project Manager, Ray Arnold for Operations, and then me. I was in charge of informatics. Dennis, who you might be familiar with from the documentary, reported up through me. So, with introductions aside, as my good friend Ray Arnold used to say, hold on to your butts, let's get into this. So first we're going to start with build. We built a lot of software at Jurassic Park. We made a bunch of our own things. And some of it was a good idea and some of it was a bad idea. But why would we ever choose to build a piece of software on our own? Well, when you choose to build something, by definition, it is unique. It's going to solve your problem in a way that nobody else will ever solve it. The system we build for ourselves is unique to our own problem, our own context, and our own tolerance for risk, which might have been slightly lower than your tolerance for risk. No one else, no other piece of software, no vendor, no open source package is going to solve your problem quite as perfectly as you're going to solve it for yourself. But more importantly, build is just fun, especially as developers. We don't want to buy software. We don't want to use somebody else's solution. We want to build it ourselves. Building is fun. Our developers want to code. We want to solve new problems. And building things, taking on this greenfield side project, allows our developers to get out of the tedium of supporting our day-to-day legacy system and play with new tech, new ideas, new concepts. Building software improves the morale of your team and lets you harness the passion of the people that you have. And in some cases, lets you acquire new people to join your organization. Like we did. We hired Dennis to join our team largely by harnessing his passion for security systems. He really wanted to code his own door lock videotaping automation system, and by telling him that we would allow him to build that himself, we were able to bring him into our organization. And I think that was a general benefit for us all. As we start digging in to any given project, we realize fast that the devil is in the details. You solve a problem with code. If you solve like the happy path where all of your servers are online, all of your services are fast and available, and the user enters input exactly as you expect it to, that's easy to get done. All of the hard parts are what about the edge cases? What if the server goes offline? What if you lose a RAM module? What if the user enters garbage into the input? All of these things are going to complicate that piece of software you build, and in many cases, it's going to be upwards of 80% of the total amount of work you're going to do. How many of you have gotten the happy path done and said, oh, it's 80% done? Well, the last 20% takes twice or 3 times as much time handling all the weird edge cases. Those edge cases are really, really important for a piece of robust software that you're going to want to run. Things, when you don't handle the edge cases, you end up in situations like this. Here is a situation where we were suffering a power and systems outage, and we really needed to interact with the door locks. Unfortunately, the door locks were dependent on having connection to power and connection to a network to lock. There was no physical knob to actually lock the door to keep things we didn't want in our operations center, totally unrelated to dinosaurs, out of the data center. But in a lot of ways, we were doing IoT before IoT was cool. This was early IoT. This was a door lock that was powered by our systems. We just didn't handle every failure case we needed to. If you do choose to build a piece of software, handling your own maintenance time is going to add up. It's going to become incredibly important. Bugs, patching, security, integrations, debugging why your headlights are running on the car batteries, 1,000 little annoying things that are going to have to happen to your software months and months after the original system was built. And this is where the true cost of successful, valuable software lies, which could be as much as 90% of the total cost of a project. For example, if you take 3 months to build a piece of software and you release it, and it's wildly successful for the company, you might be maintaining it for 10 years while the company's extracting value from it. And that cost really adds up. When we build software and we're going to deploy it into our own environment, we're responsible for maintaining the health of that piece of software. We're going to have to spend time not only building it initially, but building in all of the observability and monitoring and metrics gathering that we'll need to know to see, does this piece of software work effectively? Make sure that we know when it isn't. Make sure that we know if the fences are no longer being electrified, we should know about that right away. And this is going to take a lot longer than you think to get it right, because you're going to have a lot of cycles of failure where your systems are going to go offline and you'll realize, oh, we didn't have that kind of metric. We weren't monitoring for that kind of failure case. And then on your alerting side, you're going to have to find the right balance of being woken up at 2 a.m. when you want to be woken up at 2 a.m., but not being woken up at 2 a.m. every day. Finding that right balance is really important and really hard when you're building large, complex systems. Of course, maintenance time is going to come due when you've forgotten how the whole thing works. It's not going to come after you've just built a piece of software and shipped it. It's going to come years later when you've moved on to bigger and better things. Or maybe it's the next developer who's come into your company and taken over it. You'll have moved on to other things, but you'll have to remember how to clear the caches in your system, or recycle underlying services, or upgrade the infrastructure, or check the internal logs. All kinds of things that are going to crop up when you don't remember how to do it anymore. And you'll have to depend on documentation that you might leave for yourself, or your team left for you. But honestly, that documentation, it probably sucks. It's probably incomplete, and often it's just wrong. And you're going to have to spend time understanding which one of those things is it. Triaging the system yourself to figure out what is true, what is not true, so that you can do the maintenance work you need to do. That's all time-consuming and expensive. Of course, an outage, when the system actually goes down, is going to compile all of those other stressors of maintaining your software with the added stress of your VP shoulder surfing over you, asking, is it fixed yet? Is it fixed yet? Is the service online? Customers are waiting for you. Outages are part of this maintenance time. As we all know, things don't always go as planned. Sometimes systems go down. Sometimes electrified fences go offline. Do you know how to restart it? Can we get across the compound to flip the breaker without dying? These are important things to consider when thinking about how is your system going to break. If your system does go offline, are your backups good and current? How do you know? When's the last time you actually restored from your backups? All these things, you don't necessarily think about them until the outage happens. Now, a common concept that goes along with maintaining software is a concept called the bus factor, which some of you might be aware of. The bus factor is how many people in your organization would need to be hit by a bus for you to be in trouble. So much of our knowledge about how our systems work, how they function, is locked up in our heads, and we can't get them down in documentation, or it's just not cost effective to get it down in documentation. Our engineers, our support staff, our operations people know how the company works. And how much that information is stretched around is going to drive what your bus factor is. Of course, we didn't really have buses in Jurassic Park. We did have Dilophosauruses. And so we had a Dilophosaurus factor. How many of our engineers would have to be eaten by a Dilophosaurus for us to be in trouble? And unfortunately for us, that number was 1. One engineer had to be eaten by a Dilophosaurus, and we were in trouble. Having that low Dilophosaurus factor creates all kinds of sustainability issues in your organization. How are your teammates going to come up and help you out when you become unavailable? This can happen for lots of reasons outside of Dilophosauruses. Large organizations especially tend towards creating fiefdoms of knowledge as they specialize their teams and are not really good at sharing that knowledge between teams, which, although it might make you more efficient, it dramatically lowers your Dilophosaurus factor. Standards, documentation, and transparency can help, but you can never be truly redundant. One particular time at Jurassic Park, we were building this large piece of software, and we needed some outside help. And so we'd hired 3 different consulting teams to help us build different parts of the software. Unfortunately, our management, John Hammond, he didn't really understand how software works all the time. And so he'd incented each of these teams on their own, how many features they had shipped. And nobody was really incentivized on the success of the project. And so they were actually incentivized to hurt each other by not taking the load off of somebody else or not making the documentation completely correct for how one of the other teams might want to integrate it, which led to all kinds of infighting, where the team from this consultancy would be sabotaging the team from the other one in order to make themselves look good, but the product just burned. So all of these things come together, and we have to figure out some actual numbers on how much it's going to cost us to build a piece of software. Engineers are expensive. It's going to take time and money for them to build something. And then, as we've already talked about, that maintenance time is going to be upwards of 10 times the total cost of building it. And so we found this calculator online that lets us kind of quantify some of this, where we can put in things like the number of employees required to build a piece of software and what the average employee salary is. So at the time, we were trying to justify Dennis building a piece of security software. And we thought it would require 2 employees, and at the time we were paying $120,000 in average salary. They thought we would be able to build this thing in 2 weeks and need 1 day a month going forward to maintain it, do patches, that sort of thing. And in comparison, we looked at, well, what if we just buy it? We found a comparable piece of security software that we could get a license to for about $3,000 a year. And so if we compare these things, we can figure out, well, what does it actually cost us to build if we just multiply the salary out over the number of days? And it's going to cost us $9,000 to build it, which isn't so bad. I mean, that's fine. But the thing that really kills us is that 1 day a month adds up. That 1 day a month turns out to be $7,800 a year, every year that we are holding onto this software, which totally kills any benefit of strict financially building it versus if we could have acquired the piece of software for $3,000. So we ran the numbers, and that didn't actually seem to pay off. But there's other benefits to running your own software, right? It's fun to build it. You get to do all kinds of things. So maybe $4,000 is worth it, that loss. But the strict costs are not the only one we need to consider. Each of our companies is doing something amazing at the heart. At Jurassic Park, we were building dinosaurs. Why would we build security software when we could be building dinosaurs. That's opportunity cost, is what could you be doing with your time that serves the core of your business, the core of your organization or of your team. What could you be doing to further that goal opposed to building a given piece of software? And that is where so much opportunity is missed, where we waste time building some little print-to-PDF thing instead of buying a piece of software, or we build our own CRM instead of buying one. We do all these other things that aren't part of our core business. We did this all the time at Jurassic Park. We weren't really focused on building a bigger, badder, meaner dinosaurs, which is what would have made us successful. So if we look all that together, think about the cost required to build. There's first the creation time. How much time are we going to invest, our developers, our operations, our testing, our designers, to build out the software initially? And then thinking in terms that it might be as much as tenfold if it's successful. What is the time it's going to require to maintain this software over time? We're going to throw it into our environment. We're going to really do some stuff with it. And what is the opportunity cost? What else could we have done? What other dinosaurs could we have created? As you make decisions, and you make more decisions to build software, your portfolio of software that you're going to maintain is going to become larger and larger and more complex. At Jurassic Park, we had all of the problems of a major theme park and a major zoo and a major software provider, and our computers weren't even up on their feet yet. We didn't have a whole lot of what I call organizational maturity. We weren't able to really understand how to be a high-performing software team. If you have lots and lots of custom software, you're going to need boring things like software ownership policies. Who's going to own when changes are going to go into this software? Who makes the decisions on change management when you need to change an API and inform all the downstream consumers? Planning horizons of when a system is going to be retired, when a new one's going to go online, when things are going to change, when things are going to get patched. All of these, organizational maturity things that you'll have to do in order to be effective and your systems not to go offline. But as an engineer, that doesn't seem very fun. Engineers don't want to sit in change control meetings. They want to sling code. And so, as you think about building more and more pieces of software, to be successful at building everything you need is going to demand a very high level of organizational maturity of you. And so the question to ask yourself is, do you have it? Is your organization capable of building all of the software themselves? And even if you are, do you want it? Because frankly, maturity is overrated. And those kind of things are really boring, and they're required lots and lots of layers of middle management that are going to get in the way of your true organizational mission. If you buy pieces of software or buy services to provide them, those change control things are already baked into those packages, and you can get away with being a very immature organization that delivers the core piece of software that is really unique for your business and get to just play around and have a good time, focusing on the one thing that really matters. So those were some stories about building. We built a lot of software at Jurassic Park, probably too much, but we did buy a lot too. And so in the context of this, what do I mean by buying software? Because there is software we still buy, but a lot of people, just download software off of GitHub. They pull an open source package and they weave it into something else they're doing. But I think there's a lot of parallels in what to consider between using somebody else's software, whether you exchange money for it or not, versus whether you build it yourself. And so for the purposes of this talk, I want to think of it as build versus use. The same challenges are going to apply if you pull somebody else's package versus you are buying a service or a box software or whatever. So probably the most important benefit to using somebody else's software, to buying software from a vendor, is that it's fast. I have problem X. Vendor has a solution to problem X. I give them money, I have now solved problem X. Done. No developers, no project plan, we're just done. It's great. We bought a lot of things at Jurassic Park. We needed a smart piece of touring equipment to take our visitors around. We could have designed it ourselves. We could have built our own vehicles that did everything we needed. But we could buy it from Ford and just like clamp it to a track and get like 90% of what we needed right there, and did it so much faster without having to invent our own vehicle manufacturing process. And that enabled us to focus on the few things that were truly unique about our problem. Things like night vision, poison-resistant windows, and a T-Rex strength roll cage, which didn't come as pre-defined packages from Ford, unfortunately. But as I think we all know, even though buying is fast, buying sucks. As developers, we do not want to buy somebody else's software and implement it. If you walk into your job on Monday and you said, hey, we just signed a big contract with SAP and you're on the implementation team, that would not be a great time for everybody, I am sure. That is probably not what developers want to spend their time doing. The software we buy never works quite the way you need it to. It never behaves quite the way you'd want it to. And when something goes wrong, there's often little to do when the T-Rex-proof sunroof breaks, except find the phone number and call Tier 1 support and try and figure out their way through it. We bought a lot of big pieces of software at Jurassic Park. Here's an image of one of our implementation phone calls taking place when we were installing it. We had this big project that had been going on for 3 years. It was a 3-year project. We had 24 outside consultants to help us manage this. We had buy-in from the top of our organization. John Hammond himself had approved that we were going to implement this piece of software. We had hundreds of planning, design, coordination, implementation meetings, the kind of meetings that just pack your whole day. Your schedule is bricked from 8 a.m. to 5 p.m. every day. We even had a project manager with a shotgun ready to step in case something went wrong. Despite that, the project failed. Over half of software implementation projects fail, according to this survey from CIO magazine in 2016. Over half. Over half of software implementation projects fail. And we still keep doing it. We still think it's a great idea. Buying isn't the surefire plan for success. It's not always going to work out. And there's a lot of reasons behind that. As you start going down the process of buying a piece of software, the first thing you're probably going to run into are vendors. Vendors ready to tell you about the solution that they have. Sales presentations, box lunches, they're trying to convince you that they have the solution to all of your problems. But of course they don't. They'll probably try and sell you on one of two options on how their software works. But most vendors tend to fall into one of these two kind of silos. The first is that there are industry standard. Is that if you have this kind of problem, we have the solution to this kind of problem. We sell it in this box. You just have to install it and the problem will be solved. We had some problems like this at Jurassic Park. We had a complex engineering effort that we called Design to Hatch. And it was part of our genetics program. We would design the genome, go through a number of testing series, synthesize an egg, manage the egg until it hatches. That was our design to hatch phase. And there was all kinds of complex things that went into that. In some cases, different steps in that were truly unique things that we needed to do. But in others, we had the same problems that everybody does. We needed to manage eggs, keep them at a certain temperature until they hatched. Well, they have to do that with chickens too. They have to do that with all kinds of eggs. And we were able to purchase a piece of robotic egg management software that just plugged right into our process, and we had to do nothing at all. In fact, adopting the process that came out of this piece of software improved our efficiency because we weren't as good at it as this piece of software that was used worldwide. Most software assumes a given flow of work inside of it, a given process that your users or your systems are going to follow. And in some cases, the flow of work that they expect is what you're ultimately buying. You're buying somebody to tell you what the process is for this so that you don't have to figure it out for yourself. We saved a lot of headache by just taking their process and moving forward with it. Another great example of industry standard is when you're buying operating systems. Very few of us need to code our own operating system. And although we considered it at Jurassic Park, we ended up using a standard Unix variant, which allowed us to onboard interns very, very quickly when they came into our system, immediately recognizing the underlying code the underlying system that was operating. The other option that vendors will try and sell you down is that it's highly configurable. You can take our software and you can tailor it to the specific needs of your business. So in other cases in our design to hatch system, we needed something that was really configurable. There were some genetic things that we were doing in Jurassic Park that were truly unique and nobody in the world had ever conceived of it. We needed software that could adapt and change and be exactly what we wanted it to be. A very common use case that might be relevant to all the software people in the room would be Atlassian's Jira product, which is highly configurable to project management and issue tracking in software spaces. It allows you to change all kinds of things about what fields you're going to track, what workflow you're going to go through, what alerts get sent out, and what stages things can go through. Unfortunately, you have to assume that your process is superior to theirs. You're saying that our process in building software, in the case of Jira, is so much better than what anybody else is doing that we need to configure a tool to codify our process because it's just so much better. Unfortunately, if your process isn't that good, you've just made changing it all the harder by coding it into another piece of software to make it go wrong faster. Something that you'll have a problem with all vendors of buying a piece of software is this concept called vendor lock-in. So if you go down that path of buying a piece of software, you need to think about this. The more you customize a piece of software, the more you tailor it to your needs, the more you're locking yourself in to continue using that piece of software. The more expensive it's going to be for you to ever leave that piece of software. You're making that cost to switch away from it more and more for every time you configure it, add your own custom code to it, or further complicate it. Recreating all of that configuration is expensive. And the vendors are aware of this. In fact, they're optimizing their product for it. It's a term that they call being sticky. Vendors do everything they can to make their products sticky. And you need to be aware of it as consumers. As you choose to use a product and you continue to adapt it, if you're using a piece of code that requires you to write in their own custom language or use their own custom way of defining properties, you're making it harder for you to leave. A really common company, or a company that is really good at being sticky, is Salesforce.com. Does anybody work for Salesforce.com? No, that's fine. This isn't bad about them. This is a great product for them. But the product that they launched allowed you, as a company, if you were to acquire a license to Salesforce.com, you would code your own custom things in there. But you wouldn't use an industry standard language. You had to use their language, which was called Apex, which didn't work like any other language. It was theirs. So every line of code you'd write in Apex was bound to Salesforce. You couldn't ever copy it out and put it into your own system. The database design and how you'd go about querying it was also custom. It was not quite tables, and you would query it using a language called SOCL, which wasn't quite SQL. It was just hard enough that you couldn't copy it out and use it anywhere else. They made their product very, very sticky, and they are one of the largest cloud companies in the world. Together, all of these problems with dealing with vendors, buying software, and the complex implementations of them lead to this effect called the not invented here syndrome that a lot of companies tend to have. Buying, installing, and integrating software often sucks. And so we have a tendency as engineers to overbuild, to avoid that pain. We build our own monitoring systems, our own tour operations, our own telephone systems, our own video surveillance and door locks. We had not invented here syndrome bad at Jurassic Park. Here's an example of a case where we chose to buy a piece of software because we thought that somebody else could solve this problem better than us. So at Jurassic Park, we had some volatile assets that we needed to manage. And there was a hot startup coming out at the time. There was a hot startup coming at the time called Raptor. And they were supposed to specialize in securing the most unsecurable, volatile assets around. They were featured in all kinds of financial technology and cryptocurrency and some physical assets. And we thought that this is the company that we want to work with for helping us with our volatile assets. They were featured in a bunch of tech press, the community buzzed about them, and so we implemented them. And it looked good. Everything looked favorable at the beginning. But a lot of the capabilities that they claimed to have didn't quite manifest when we started putting it together. A lot of the things that they said they could do were kind of pumped up by the venture capitalists that backed them and not really in the core product itself. And like many other software startups, as core, it wasn't a profitable company. It had taken lots and lots of outside money and didn't make any of its own, didn't make enough to continue its operation. Now there's lots and lots of great software vendors that are unsustainable early on. But the trouble happens that if something goes wrong, they might not have the foundation to survive it. And in the case of Raptor, Raptor had a lot of customers in the cryptocurrency space. And buried somewhere deep in their software product, they had a dependency on this package called Event Stream. Now, some of you might have heard of the Event Stream situation that happened. Event Stream is an open source package that was maintained by a very nice gentleman. And it was just a small library at the core of many pieces of software. But the person supporting it was overworked, wasn't getting paid, had a lot of other things on his plate. And when a kind person said, hey, I want to take this over, here I have a reputation, I'm good, they handed over the project. Seemed good. Except the person who took over the project injected a cryptocurrency theft mechanism into it and deployed it out via the NPM package management system, which was then picked up by all of these other pieces of software, including some core pieces that were used by Raptor. All of a sudden, Raptor had this tremendous liability. All of its cryptocurrency customers were seeing money taken out of their accounts, and they couldn't cover it. So on one Thursday night, Raptor just disappeared. Oracle acquired the assets, shut down the company, and Raptor was gone, which is the unfortunate side effect of companies that aren't underlying sustainable. Is when something goes wrong, they can just disappear. On Monday, they can be, we're crushing it and everything's great, and on Tuesday, they're filing for bankruptcy. So it comes down to sustainability. Both sustainability in a vendor that you're looking at or sustainability in that open source package. Is how are they going to continue? How are they going to still be there for you when you need them? If your business is depending on an open source package that's entirely maintained by one developer in his off hours in the basement, that might not be the core business that you want to build on. Maybe you want to contribute to them. Maybe you want to donate to that open source developer. Maybe you want to give some time or energy back to them. Or maybe that's a case where you want to build your own, if you think that that's something truly unique to what you're doing. So we talked a bit about build, and we talked a bit about buy. But how do we decide? So far, those have just been anecdotes about how things have failed for us in the past. And we need to look forward to the future. And how are we going to make these decisions about the new things that we're going to build? For the last one, we definitely had some well-deserved mud on our face. We failed as an organization. I failed. I probably got too far away from the software in my VP role. But only 4 people died. Our lawyer's dead, our project manager's dead, Mr. Arnold is dead, and Dennis is dead. But that's it. That was all it was. We can do better. How can we do better for the next time? And so I thought of 5 questions that I need to ask myself and ask of my team as we're moving forward into the next Jurassic Park. Questions like, what is the impact of failure? When we're making a decision, how wrong can it go? Let's say hypothetically, everything goes wrong. I know it's not likely, but let's just humor me and say everything goes wrong. The power goes out, the fences go down, all at the same time. What's going to happen for this decision that we're looking at right now? What is the impact of failure? Do people die? Does the business lose a bunch of money? Is the engineering team inconvenienced? Does something just show up in the logs? What are we talking about here? Because we should focus on when people die and when the business loses a whole lot of money. Those are the important decisions that we need to get right. An alert getting sent at the wrong time, maybe we don't need to spend a week in analyzing what the right decision is here. So don't get sucked into analysis paralysis. Focus on the big decisions that are really going to matter. Second, when we're deciding on something, do we need competitive advantage or competitive parity? And these are the words that like a bunch of our MBA consultants like to use, and I don't know, they're big and nasty words. So one of our other architects that we're working with right now, Dylan Beatty, phrased it this way, that if you couldn't sell it, buy it. And I think this is a much more eloquent way of putting it. But we need to clarify, because in this open source world, we're going to depend on a bunch of new open source packages. We should think about if we couldn't contribute it, we should buy it. If we're making a decision about a piece of software, and we don't think that software is novel or interesting enough that we could wrap it up and put it out as an open source package that other people could use, then is it really novel and interesting and valuable enough for us to spend our time on? Or should we just go use it from somebody else? If we're thinking about building our own web framework, but we don't think this is good, this is interesting or unique enough that we could go out and put it up next to React and Vue and Ember and Angular and the rest, well, do you really need to build it then? Or could you just use something from somebody else? Question 3, what is our bias? All organizations, all teams have bias. Here's a picture of us doing some mob programming. We're reviewing a bunch of Dennis's systems after he left. While we reviewed it, we noticed a bunch of bias in his choices. There was over 3 million lines of C code in there, and there was a tremendous bias for building. Every little subsystem he built himself. Every single thing that we needed to call out to. If we needed to get water pressure for our sprinkler system, he would call out and build that himself. He built every subsystem without ever reaching out to third parties, which seemed wasteful. It seemed like we didn't really need to do that. Gave the system a lot of control to short circuit the system should he ever need it, which I'm not sure why he would ever want to be able to do that. Question 4, what could we do with our time instead? So should we build our own security system? Or should we build a bigger, scarier dinosaur? And I think when we weigh those together, I think the answer is clear. We got to build a bigger, scarier dinosaur. That's what we're good at. That's what our organization excels at doing. And we need to put all of our attention there. And the 5th question, and probably the most important of them, is it sustainable? And this question applies whether you're building it, buying it, or using it from an open source provider. If you're building something yourself, are you mature enough of an organization? Do you have the time and resources to commit to not only solving the core problem, but solving all the edge cases, getting it all the way to production, managing it once it's there, making sure it's available? Are you capable of doing that with this new venture? Or if you're going to buy it, is the company you're going to buy it from, are they still going to be around in 2 years when you need them? Are they an organization that's going to be there to support you when you need it? Or if you're going to pull it from an open source provider, are they built in such a way that there is a corporate sponsor behind that package? Or there is a fee that is being paid to the contributor to make up for their time? Making sure that you're not depending on something that is just going to disappear when somebody burns out and walks away. So these are important questions that I think we need to ask for the next time. Next time, we're going to do this right. One of the problems that we had with the last park was that it was just too remote. It was too far away. It was too isolated. We couldn't respond to the needs on the ground fast enough when we had an issue. And so I'm super excited to announce our next park. Right here, we're finalizing plans to build the next park right nearby. It's part of Hyde Park in London, further amplifying the cultural center that is this great city. We're actively hiring, especially in Raptor operations. So if you're looking, please come by for an application afterwards. The last time when we were building up our systems, it was not very flexible. It was too concrete. And so this next time, we're going to write it in modular JavaScript. All of our systems for the new Jurassic Park are going to be JavaScript. And we've hired a new chief developer named Newman, who's fresh out of a code school after leaving the US Postal Service, and he's got some great ideas about complex distributed event systems that we want to try. But we're already coming up against these questions about what parts of this do we build and what parts of it do we buy. And so to kind of amplify my points here, I want to walk you through one of the decisions that we've just gone through recently, which is how are we going to monitor our system for when it's going to go down? So because the new Jurassic Park is built on JavaScript, and like a lot of JavaScript apps, they break in sometimes unpredictable ways, we need to understand when it breaks and alert the proper people so that we can respond to issues. So for the next park, we've already been looking into this, and we've been weighing a couple of different options. So first, we looked at building it, and what would be required if we were to build our own monitoring system. And so first, we would need to write some JavaScript as like an agent, something that we could collect data from all of our other systems with. And we know how to write JavaScript. We're doing all of our systems in JavaScript. We could probably do that. But then we need somewhere to put all of our monitoring data. And so we could look at open source packages like Elastic and shove some of it in there. And that kind of solves part of the problem. Now we're collecting data and storing data. But I also want to report on it and see, well, what happened yesterday? What's going wrong? And so we'll need some visualization tools. So we could use Kibana or Grafana or a number of different tools to look at that. But that's kind of the happy path. That's the core things you need for this system to come online. Well, you're also going to want alerting built into that, right? You're going to want to know when something interesting happens. And you're going to want to look into the data and see about anomalies of when something is increasing in importance. And then you're going to figure out, well, what happens if the system goes down? We need to back it up. What infrastructure are we going to run on? How many servers do we need? What's the security? Do we need to lock down our server? Are we putting sensitive data in our logs? Do we need to keep this secure? What happens if the monitoring goes down? Who monitors the monitors? And if so, who monitors the monitors of our monitors? How do you solve these problems? So here's where we get into all those niggly little details that are going to eat up so much of our time trying to solve this core problem. So we ran it through that calculator, and we put together a project plan of, well, what do we think it would take? So we thought Newman could probably put it together himself, and we're paying Newman a little bit less because he's a newer developer. We're paying him $100,000. He thinks he can build this in 4 weeks, and we think we need about 1 day a month of maintenance, just to make sure that all the apps are running smoothly, all the agents are deployed, we're gathering the right data. But as part of gathering this, we looked out on the marketplace for what else could we buy. And so we found a comparable tool for about $2,700 a year. And so all right, well, does this ever pan out? So just using those numbers, we see it costs us $7,600 to build the system originally, but another $3,200 every year to maintain it. That 1 day a month adds up. And so if you compare that to other systems, this never actually is a pure good idea. Like you're losing money every year. Well, that's one facet of this, but what if we go down the path of buying it? And is that sustainable? Is that a good idea? So we looked at one vendor, and we looked at sustainability specifically. With if we were to go to them, are they still going to be there when we need them? One of the biggest factors in sustainability in software companies is outside money. If a company takes a bunch of outside investment, that outside investment puts a tremendous amount of pressure on that company to grow. And in fact, numbers show that 99% of the time, a company that takes outside investment will fail. So if you look at that, that's a strong signal that that company might not be around later. And speaking with the leadership of the Track.js team, they've said they've never taken any, they don't intend to, and that they are already internally profitable. But most importantly, we have to consider our opportunity cost here. So we could spend this, it's not that much money. We could go out and build our own monitoring tool. That'd be fine. Or we could take those 2 weeks, 4 weeks, and 1 day a month and build a bigger, scarier dinosaur for our London park. And I think that's what we all want, right? We want a bigger, scarier dinosaur here in London. Should we build monitoring software, or should we buy monitoring software and have more time for dinosaurs? I think that's clear. I think Newman's going to agree. So that was build versus buy. To kind of wrap up, some questions that you should ask in your teams when you're trying to make this decision. One, what is the impact of failure? Figure out, should you even spend time thinking about this, or should you just go with your gut and move on because it's unimportant? Second, could you sell it? If you're thinking about building something, but you don't think it's interesting and valuable and unique enough that you could sell it, then it's maybe not as novel as you think it is, and you should just buy something. Understanding what your bias is, simply so that you can recognize it and make a conscious decision about whether or not you're doing something just because you tend to always build or you tend to always buy, and think about it. What could you do instead? If you were instead of buying something, or instead of building something, what if you took those 2 weeks, 4 weeks, 6 weeks, whatever it would take, and you invested it somewhere else, in a core product extension, whatever, in building a scarier dinosaur? And regardless of which path you go down, understand whether or not it's sustainable. Is the path that you've chosen sustainable by your company, or the vendor, or the provider that you've chosen? And with that, those are the 5 questions I think are important for us to ask ourselves when we're choosing whether to build, buy, or use software. And in the words of our consultant, Dr. Ian Malcolm, well, there it is. Thank you. And with that aside, if there's any questions, I'd be happy to chat. There's a bunch of stickers up here if you'd like any.
Maybe about the bias. Like if we figure out we have a bias for building, would you then say, okay, if you like building, just continue building?
No, I mean, if you recognize that your organization has a bias to build, which a lot of engineering organizations do have that bias, try and look at where did that come from. So are you building because you're really good at it and it's been successful for you historically? In which case, yes, continue. If your past decisions on building things yourselves has left your organization in a healthy, sustainable state, keep doing it. But if the last couple times you've chosen to build something, it ended up a hot mess and you didn't really want to run it anymore, and the developer who was running it ended up quitting, maybe that's not such a good decision anymore. And you should recognize that you're making that decision implicitly. There was one organization that wasn't Jurassic Park that had, it's a large company where I live. They have a tremendous bias for building. The not invented here syndrome is strong with them. They have invented their own cloud layer that looks a lot like DigitalOcean, does the same thing as DigitalOcean, but is their own thing. They built their own Dropbox and their own Twitter to solve basically the same problems, but only in their company. Like, it's just theirs. And those don't really make sense. Like, none of those systems work well. Nobody who's ever been at this company has enjoyed using them, but they just like owning their own software. They don't trust external vendors regardless of who they are. All right, thank you very much. Enjoy your evening. If you have any other questions you want to chat with me up here, feel free. Thank you.